Our Milky Way galaxy is a vast and ancient structure. It began its life over 13 billion years ago. Back then, the universe was young. It was filled with clouds of gas and dust. These clouds were mostly hydrogen and helium, the simplest elements. Over time, gravity pulled these clouds together. The clouds swirled as they collapsed. This swirling motion caused the Milky Way to take on its spiral shape. As more gas and dust clumped together, stars began to form. The first stars were massive and short-lived. They exploded as supernovas. These explosions scattered heavier elements throughout the galaxy. These heavier elements would eventually become the building blocks of planets, moons, and even life itself. The Milky Way continued to evolve. It grew larger as it merged with smaller galaxies. Today, it contains billions of stars. It is still an active and dynamic place.
Stars are the cosmic engines that light up the universe. They form within massive clouds of gas and dust called nebulae. These nebulae are scattered throughout the Milky Way. Gravity plays a crucial role in star formation. It draws the gas and dust within a nebula toward its center. As the material collapses inward, it heats up and spins faster. Eventually, the core of this collapsing cloud becomes so hot and dense that nuclear fusion begins. This is the process where hydrogen atoms fuse together to form helium, releasing tremendous energy in the process. This energy creates outward pressure that balances the inward pull of gravity. A star is born. Around these young stars, leftover gas and dust can clump together to form planets. This process, known as accretion, occurs over millions of years. Dust grains collide and stick together, gradually growing larger. These larger bodies attract more material through gravity, eventually forming planets and other celestial objects.
Our solar system is located in a quiet arm of the Milky Way. It is about 26,000 light-years from the galactic center. At the heart of our solar system lies the Sun, a yellow dwarf star. The Sun's immense gravity holds 8 planets in orbit around it. These planets, in order from the Sun, are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Each planet has its own unique characteristics. They vary in size, composition, and distance from the Sun. The inner planets, Mercury, Venus, Earth, and Mars, are rocky planets. They have solid surfaces and relatively thin atmospheres. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants. They are much larger than the inner planets. They are composed mostly of hydrogen and helium.
Section 4. The planetary lineup. From rocky dwarfs to gas giants. The planets in our solar system are a diverse bunch. Mercury, the smallest planet, is a scorching hot world. It is tidally locked to the Sun, meaning one side always faces the star. Venus, often called Earth's twin, is a hellish planet with a thick, toxic atmosphere. It experiences a runaway greenhouse effect that makes it the hottest planet in our solar system. Earth, our home, is a unique planet. It teems with life thanks to its liquid water, moderate temperatures, and protective atmosphere. Mars, the red planet, is a cold and dusty world. It has a thin atmosphere and evidence of past liquid water on its surface. Jupiter, the largest planet in our solar system, is a gas giant with a swirling storm known as the Great Red Spot. Saturn, known for its stunning rings, is another gas giant. It has numerous moons, including Titan, which has a dense atmosphere and methane lakes. Uranus, an ice giant, is tilted on its side. It rotates at almost a 90-degree angle to its orbit. Neptune, the farthest planet from the Sun, is a blue giant with strong winds and a faint ring system.
Section 5. Pluto's demotion reclassifying a celestial body. Pluto, once considered the 9th planet, was reclassified as a dwarf planet in 2006. This decision was made by the International Astronomical Union, or IAU. It sparked debate and controversy. The IAU established 3 criteria for a celestial object to be considered a planet. First, it must orbit the Sun. Second, it must be massive enough for its own gravity to pull it into a spherical shape. Third, it must have cleared its orbital neighborhood of other objects. Pluto meets the first 2 criteria, but not the third. It shares its orbit with other icy bodies in the Kuiper Belt, a region beyond Neptune. This reclassification highlights the evolving nature of our understanding of the solar system. It acknowledges the diversity of objects beyond Neptune,